Hello everyone, I am Shima, the team lead for the GAP department of NGCC Software Technology. Continuing the ETABS classes, today we will look into the types of materials which we use to create a structure. Uh, there are two types of materials we have. The first one is the concrete. Okay, and the second one is steel. There are two types of materials we use, concrete and steel. So let us first look into a detail of the concrete structure. Okay, so there are four materials used for the concrete structure. First one is the cement. Second one is fine aggregate. The third one is the core aggregate. Okay, and the next one is the water and cement ratio. So there are four things under concrete, which the first one is cement, the fine aggregate, core aggregate, water and cement ratio. So let us first look into the cement option. Okay, in cement, why is cement used? First of all, cement is basically used as a binding material. Okay, cement is used because it binds or it holds all the material which is used to create the concrete structure. Okay, so it basically holds everything, it binds everything together so that it is quite rigid, it doesn't loosen everything or loosens the material which has been mixed together. Okay, so the type of cement we use mostly type of cement we used is OPC. What is the full form of OPC? Ordinary Portland cement. The type of cement we use is the ordinary Portland cement, and the grade of cements are cements are 33, 43 and 53. Okay, under which the most commonly one used is the 43 grade. Why is 43 grade used most commonly is because it gives us a very good, it is a very good hydrator basically, and it has good minerals in it. It will not dry. I mean, when the cement is mixed, as we all know, it gets dries after some time. But this 43 grade cement will not dry very fast, uh, and it gives us a gives us a good hydration. That is why this is the reason we use the 43 cement. 53 cement is also used sometimes, but it dries off very fast. We have to put a lot of water for it to get that grip. But 43 also needs water, but not as much as compared to the 53 one. So 33 is very less used, not used at all because it does not have a good hydration property. That's why. Okay, the cement weigh the cement bag weighs around 50 kilos. 50 kilos, and the unit weight of cement is 1440 kg per meter. Right. This is about cement. The next thing is fine aggregate. What is fine aggregate is, it is nothing but the sand which we use to mix inside the cement while mixing the concrete. Okay. Now, how is this fine aggregate? How do we get this fine aggregate? What we basically do is we pass this material into a sieve, and the material which we get after it passes the 4.75 sieve is called the fine aggregate. So basically, material that passes the 4.75 sieve is the fine aggregate. Okay, and what is the use of the fine aggregate? Why is this being mixed into the material? Because what it does, it as it is very fine, it fills up the voids inside the material. Voids is nothing but the gaps, the small gaps which we get. It fills up the voids inside the material. That is why we use the fine aggregate. The next one is the coarse aggregate. Okay, now what is coarse aggregate? The material which we get or we retain on the 4.75 sieve. I mean, it does not pass through it, but it is on the 4.75 sieve. That material is called the coarse aggregate. It is basically retained on the 4.75 sieve. Is coarse aggregate. Okay, and why is this used inside the material is because it gives strength to the material. It being it's not that fine as compared to the fine aggregate. It is a little rough, a little thick when compared to fine aggregate, and that is why it gives us a strength in the material. That is why it's used. Okay, now there are different types of coarse, the different sizes of coarse aggregate. The first one is the 10 coarse aggregate. The 10 coarse aggregate is used for beams and columns. Used in beams and columns. Okay, the next one is uh, the 20 coarse aggregate. 20 coarse aggregate is used for slabs and shear walls. Now, what do you mean by shear walls? Shear walls is nothing but the walls which are only created by cement. It does not have any bricks in it. That's called shear walls. The next one is 40 coarse aggregate. 40 is used for footings. And the next one is 80 coarse aggregate, which is used for heavy bridges and dams. Okay, so this is about coarse aggregate. The next one is The next one is the water and cement ratio. Okay, this has to be third point. Then we have okay, putting the water and cement ratio is based on the mixing design. So I'll let you know about that on later classes. It is on based on mixing design. Based on the mix design. Next one, the next thing we look into is admixtures. What are admixtures? Admixtures are used in RMC. RMC is nothing but ready mix concrete. RMC is nothing but the ready mix concrete. So it's a ready-made concrete mix. This is basically used for traveling purpose. So, I mean the main value of or the initial setting time for a cement or a concrete is 0 and the final setting time is 30. Whereas if you're using this RMC, it gives you a time limit of 2 hours for settling. That is why mainly we use this um, RMC. If you have a long traveling time of 2 hours and you will not be able to, you don't want the cement to set down fast, we use this RMC cement. So these are about the cements which you'll be looking for. We will now look into the mixing method of concrete. Okay. So as I told you, the mixture, the time taken or the setting time for RMC is 2 hours. But for a normal concrete, 0 is the initial setting time and 30 minutes is the final setting time. So if you're mixing it right away, then you have to allow only 30 minutes for it to set down. But if you want a higher time limit, then we use the admixture, that is the RMC. So next is the mixing method of concrete. There are two types of mixing method in concrete. The first one is the nominal method. Nominal method is nothing but the manual method which we have a hand mix basically. It is a hand mix. Okay. It is uneconomical basically. I mean, when we do a hand mix, we have to do it on the ground, and there's too much of material which is being wasted on the ground. It is just left on the ground. You cannot just use it completely. That is why we consider the nominal method to be uneconomical. Okay, and the mixing design it follows is M5 to M25. This is the mixing design it follows. So next method is the design method. First one is the nominal method. The next one is the design method. Okay, design method is nothing but the machine mix. This is considered as economic as it is not being wasted too much. And the mixing method, mixing design it follows is amazing. Mix design is above M25. I'll let you know about this in detail of what is M5 and what is M25. Okay. So in the next class, we will look into the mixing designs we have and also the field structure. I hope you have gained knowledge in this class, and do subscribe, like and comment to our channel on YouTube of NGCC Software Technology. Thank you.